This is my final presentation for the BRIEF 2026 Exoplanet course. My chosen exoplanet is K2-157b, and I chose this planet because it's a roughly Earth-sized exoplanet and a challenging object to observe, and different from the usual hot Jupiters that I have been observing. So the host star is K2-157 and the exoplanet is K2-157b. There are two known siblings, K2-157c and K2-157d, and these are both Neptune-like giant planets. So here's a diagram of the system. We have the host star K2-157 and K2-157b orbits very, very close to its parent star. Its siblings, the two Neptune-like planets, K2-157c and K2-157d, orbit further out. Now, K2-157 is a G-type star, a Sun-type star, located 973 light years from the Earth. So what do we know about the host star? The host star, K2-157, as I've said, is a G8V star. It's located in the constellation of Leo. Its size is 0.860, the radius of the Sun, and the mass is 0.890, the mass of the Sun. The temperature is 5334 Kelvin, and in comparison, the Sun is 5772 Kelvin. The metallicity is 0.02. Here's a diagram of the system showing the star and the exoplanet. You can see it's quite small compared to the size of the star. And K2-157b is thought to be a potentially rocky world. So what do we know about K2-157b? Well, it was discovered in 2018. Its radius is 0.0834, that of Jupiter's, and its radius is 0.9350, that of Earth, so a bit smaller than the Earth. Its mass is 0.00359 times the mass of Jupiter, and it's slightly more massive than the Earth at 1.14 times the Earth's mass. It has a very short orbital period of only 8.8 hours, and that is equal to 0.3652575 days. And it's regarded as an ultra-short period terrestrial, Earth-sized exoplanet. Orbits very close to the star. Its semi-major axis is 0.00962 astronomical units. The inclination is 89.2, and it's a very hot world. The temperature is 2432 Kelvin, which equates to 2158 degrees Celsius. And the transit depth is very shallow, being 0.00990%. So I tried to simulate a transit of this exoplanet using the Exoplanet Transit Simulator, and I put in the planetary properties here and the stellar properties there. And you can see from the diagram it's a small planet. It doesn't even show on the transit simulator. And you can see that the eclipse depth is very, very shallow. Well, what about my observation? I observed this exoplanet using the Barren site. Details are shown on the slide. And for the observation, for the parameters for the observation, I use the Swarthmore Transit Finder site. My observation occurred on the 16th of April 2026. I was able to get almost a full data set. I certainly got some of the pre-transit data. I got all of the transit, and I got all of the post-transit data that I needed. So the duration of the transit is 1 hour and 10 minutes. The depth is very shallow, 0.10. And as we've said, it orbits the star very rapidly with a period of 0.37 days. So here's my light curve. Here we can see the transit depth, rp squared divided by rs squared equals 0.0055 plus or minus 0.0012. The mid-transit time is shown here, and the A0 is 1.0003 plus or minus 0.00085. The sigma I thought was quite good at 0.28. The sigma is the comparison between the orbital model, the NASA model, and my data. Just some information about the observation. Here is the companion star. This is the corner plot. I'm sure you'll all understand what that shows. Here are the observing statistics during the observation. The X and Y centroid did move around a bit during the observation. The mass decreased as the observation progressed. So here again is my light curve. So how did my observations compare with the NASA Exoplanet Archive data? Well, looking at the transit time, my observation was 2461147.7471, and Swarthmore predicted 2461147.735. So the observed minus the computed is 0.012. The ratio of the planet to the stellar radius is reported to be approximately 0.01. My figure was higher at 0.07. However, on a previous run, I achieved a figure of 0.051. My transit depth was pretty comparable to two decimal places. It was the same. The orbital inclination was 89.2, and my orbital inclination was 84.21. And my sigma is 0.28%. The transit duration was comparable. NASA says 0.048375, and mine was 0.0497. The NASA Exoplanet Archive data comes from the most recent paper by Castro Gonzalez in 2025. So what about habitability factors? Is the planet in the habitable zone? No, it's not. Could the planet be tidally locked? Yes, it could. Can it retain an atmosphere? It's probably very unlikely given its size and location from the star. What is the radiation environment? Well, the planet orbits very close to its parent star, so the radiation effects would be extremely severe on the side facing the star. And there have been descriptions of this planet as being a lava world. What about life? Well, I think if it exists at all, it would have to be extremely exotic. Maybe one of those rock creatures from Star Trek, like the Horta from the original series episode The Devil in the Dark, screened in 1967, a silicon-based life form with a multi-rocky exterior that secretes strong acid. But I think possibility of life is, virtually zero. Here are my references. I've used the NASA Exoplanet Archive and the Swarthmore Transit Finder. So it's been a really interesting exoplanet to study, and thank you for your attention.